Everyone. My name is Nsisong Akpanudo, and this is my community analysis presentation. So, in this presentation, I'll walk through two data communities and I analyzed using the SQL Server, which is the BMW car listing and the mental disorders data set. So, each data set explores different analytical goals. So, one focused on the pricing trends in the automobile market and the other one focused on the clinical symptom patterns in mental health data. So for both, I will show how I use the SQL to clean, join, aggregate, and interpret the data to answer real-world questions for stakeholders. So here, this is my BMW community overview. As you can see here, the description, this shows vehicle listing records and model masters for price analysis. So the source I got it from Google data sets. Stakeholders include the price analyst, marketplace manager, inventory manager, and product analyst. So these are my tables here that I used, and I'll go right away into the questions. So for the first question, is basically fuel type versus average price. So the key stakeholder here is the marketplace manager. So the question goes, how does fuel type affect average clean price among vehicles within 3 model years of manufacture? I need a clean price, model year, and fuel type from BMW listing joined to model name in BMW models to compare average by fuel type within the same year range. So why this question? The goal was to help the marketplace manager compare how petrol, diesel, hybrid, and electric cars retain their value over roughly the same model here. So let's go over to SQL. So this is the question here. So what I basically did is I joined the BMW listings with BM models, filtered the listings so that each record was within 3 years, as you can see, and of its model year. Then I grouped it by the field type and computed the average clean prices. So I'm going to run the code now. So this is it. So this allowed a fair comparison between petrol, diesel, hybrid, and electric cars. So as you can see, the results show that petrol listing maintain higher average prices across overlapping model years, while hybrid and electric shows more variation. So you can see here, this is petrol, diesel, this is hybrid, and you can see how it goes and all. So the next question is key stakeholder is the inventory manager. So the next question is what percentage of listing for each model year are priced below the median clean price for that same model year? I need a clean price, model ID, and the year from BMW listings to BM model to compute medians per group, and then the below median percentage. So why this question? This helps the inventory manager dictate the pricing pressure and undercutting. So let's go over to SQL and show the demonstration. So basically, using the percentile, uh, I computed the median per model year, ID and year, joined it back to each listing and counted how many listing fell below it. So let's run the code. So this is it. So I dividing that by total per group gave the percentage of sellers, which you can see here below the median. A useful measure that we use to for the pricing pressure. So this is it. So let's move over to the next question. So the next question here is adjusted average price. So the key stakeholder here is the pricing analyst. So for this question now, I wanted to compare listing, uh, basically, let's just read over it. Which BMW model and model year combination have the highest average clean price after adjusting for mileage and engine size? So what I need is the clean price, the mileage, the engine size, the model ID, and the model name and year to run a group adjusted average. So why this question? So this helps the pricing analyst make fair comparison between listing by adjusting for obvious differences like the year, the mileage, and the engine size. So let's go over to the SQL. So this is it. So for this question, I basically created a formula, adjusted clean price. This is the formula I created. Then averaged it by the model and the year. So we're going to run through that. So this is it. So this simple adjustment penalized high mileage and rewarded larger engines slightly. Sorting by the adjusted average, which you've seen here, revealed which models truly held value after accounting for differences. So we're going to move over to the next question. This is question 3. Question 4. So the key stakeholder here is the product analyst. This was a question from my peer Robert Young. So I want to know how car prices vary by engine size, uh, fuel type across different model years. I'm curious whether larger engines or certain fuel type tend to hold their value better as vehicles age. So basically, this helps the product team have a clear view of which engine and fuel combinations keep value as the car ages. So we're going to go over to a scale, and this is the we're going to run the code. So what I did was I bucketed the engine size into ranges, which you can see here, less than greater than or equal to 1.5, which is this, basically less than 1.6 liters. Then I also did 1.6 to 1.9. Then I also did less than 2.5, then to 2.0 to 2.4. And I grouped by those bins. I grouped it by the fuel type and model year and computed the average clean prices. So this is it where I grouped by engine bin, fuel type, and model year. So I'm going to run the code. So this is it. So basically, this helped the product team identify which engine fuel combinations return value best as the car age. So this is it: diesel, hybrid, and the rest of it. So let's move over to the next question, which I'm entering my second community, which is the mental health disorder. So this is the overview. The community is the mental health disorder data set. The description, this shows patient symptoms, symptom flags, and expert diagnosis. I also got it from Gaggle data set. So the stakeholder is the clinic director, risk assessment lead, public health researcher, and the cares manager. These are my tables that I used all together. So I'm going to move over to the first question. So the first question here said the key stakeholder is the case manager. So the first question here is for each diagnosis category, what are the top 5 symptoms by prevalence? That's percentage of patients reporting them. So I need the expert diagnosis from patient's diagnosis and symptoms names slash symptoms flag from patient symptoms to compute prevalence per diagnosis and return top 5 symptoms per group. In other words, all what we just need here is the top five symptoms by diagnosis. So, why? The reason behind this is that the clinical teams need to quickly identify the most common symptom patterns for each diagnosis. For example, to improve the triage or plan resource allocation for high impact symptoms. So, we're going to go over to SQL. So, for the first question, what I basically did is I unpivoted, as you can see here, I unpivoted all symptoms column and normalized as yes responses into the binary flags, counted how many patients had each symptoms and divided uh, by the total diagnosis to get the percentage, which you can see here. So this is why I divided it by all of that to get the percentage. So I'm going to run this. Whoop. No, I'm going to run this. And yep. So the output showed the top five most prevalent symptoms per diagnosis. So they for the clinicians can plan how to prioritize it. So this is it: bipolar one, 2, 3, 4, 5. Bipolar two. This is how it goes until normal. So the next question here, question two, is the key stakeholder is a public health researcher. So the question goes, what proportion of patients have three or more positive symptoms flagged, and how does the proportion vary by expert diagnosis? I need patient ID with aggregate symptom flag, aggregate aggregated sum, that's the symptom flag from patient symptoms plus expert diagnose from patient diagnosis to compute count and proportions by diagnosis. Basically, what this question is all about is just proportion with greater than or equals to three symptoms. So what why we did this is this helps the public health researcher identify groups of patients who carry a high symptom burden and might require a more comprehensive assessment or a specialized referral pathway. So let's go over to script to demonstrate that. Question two. So this is it. So what I did basically, this question will measure what proportion of patients have three or more positive symptoms flag, as I said, across diagnosis. So what I did was the I summed the symptom flags per patient. Then I joined to patient diagnosis, then and calculated the percentage per diagnosis whose symptoms count was the greater than or equals to 3. So I'm going to run this here now. So this is it. So the Piston score 3 plus column highlighted high burden cohorts likely needing more comprehensive assessment or referrals, which we can see here: bipolar type 1, bipolar type 2, the total patients. We've seen everything, depression and normal. So we're going to move over to the third question. So the third question is here. The third question is basically the relative risk versus the suicidal thoughts. So the key stakeholder here is the risk assessment lead. So the question goes, which individual symptoms are most strongly associated with a positive suicidal thoughts flagged in the data set? I need the patient symptoms row joined to the patient diagnosis and the suicidal thoughts indicator to compute contingency tables and ratios. So basically, what um, the question three is basically asking us the focus on which symptoms are most strongly associated with suicidal thoughts. So this question is critical because it helps the risk assessment lead identify symptoms pattern that are most predictive of suicide risks, allowing for earlier screen and intervention. So let's move over to SQL to solve that problem. This is it. So I built contingency tables first, comparing patients with and without each symptom against their suicidal status. Then computed the risk exposed, risk unexposed, as you can see here, and relative risks. So we're going to run that. So this is it. So symptoms with relative risks greater than one indicated elevated likelihood of suicidal thoughts when that symptoms is present. That is it. Is early warning screening. So we've seen it here. The mood swing, expose. This is the suicidal thought. Unexposed suicidal thought. The risks exposed, risks unexposed, and the relative risk. This is the highest one, 1.4. So that is how it goes. So we're going to move over to the next question because of time. Next question goes, which is basically depression versus bipolar co-occurrence. So the key stakeholder here is the clinical director. So the question goes, which symptoms most frequently co-occur with the expert diagnosis depression compared to bipolar type 1? I need the patient ID plus expert diagnosis from patient diagnosis or mental sanitize and symptom name and symptom flag to compute concurrent and count and proportions. So basically, what this last question here is asking is for us to compare the depression and bipolar type 1 to see which symptoms occur more frequently with depression. So, as why we did this is the purpose is to support the differential diagnosis by revealing symptoms pattern that distinguish one condition from the other. That is information that can guide targeted interventions or clinical focus. So let's go over to SQL to demonstrate how that was done. So what I did was that I combined multiple diagnosis sources, created cohort for each condition, then calculated the symptom prevalence for both and subtracted to find the percentage point difference. So I'm going to run this. So as this is it. So this is basically the this column here, part different depression minus babe. Column showed which symptoms distinguish depression from bipolar type 1, which is valuable for differential diagnosis and targeted intervention. So, in summary, both communities demonstrated how SQL analytics can translate raw data sets into actionable insights, whether for market pricing, decisions in automotive data, or clinical decision support in healthcare. So basically, across both cases, the same processes applies. So what we did is to define the question clearly, prepare the data carefully, join the related tables. You can see these are my tables here, and aggregate meaningfully. So thanks for watching this my short presentation. That'll be all for now. Thank you.